Turning industrial CO₂ emissions into valuable products to fight climate change is the aim of the CAPTUS project, with the University of Cantabria and 17 other European partners involved.
The main goal of CAPTUS is to develop 3 demonstration models for capturing and using carbon dioxide, in order to obtain 3 energy carriers and 3 high-value products, in 3 different industrial locations. The role of the University of Cantabria in the project is to lead the demonstration that's being carried out, and will continue, at the cement plant located at Cementos Portland Valderrivas in Mataporcara, and to produce formic acid using electro-reduction processes. That's actually one of the lines of research we've been working on for over a decade now in the Chemical Process Development and Pollutant Control Research Group at the University of Cantabria.
This process allows scale-up from lab to pilot plant.
As part of the demonstration at the cement plant, the goal is to implement a system that can actually recycle the CO₂ released during their production process. This is part of a broader effort to reduce industrial emissions and develop cleaner, more sustainable technologies. Our focus is on the second stage of the process, converting the CO₂, which is first captured by our Norwegian partners, into something with added value. That conversion is done through an electrochemical process, one we've been researching and developing in our group for more than a decade. The basic idea is this: we feed the captured CO₂ into an electrochemical reactor. Then, we apply an electric current. It's that current that drives the transformation, turning the CO₂ into different valuable chemical products. At the center of this process is the most important component, the electrode. That's where everything comes together. The CO₂ flows in, electricity is applied, and water, our other main reactant, is introduced at the same point. All of these elements meet at the electrode surface, and that's exactly where the reaction happens. One of the major advantages of this method is that it's relatively easy to scale up. The amount of CO₂ we can treat depends mostly on the size of the electrode. We can make these electrodes by hand, using spray tools to coat them with the necessary materials. But we also use semi-automatic equipment, similar to a 3D printer, though it prints in just 2 dimensions, that lets us apply the metal layers more precisely and efficiently. That means we can build larger electrodes, step by step, and process more and more CO₂ as we move toward real industrial applications.